Okay, this first problem is on page 7. It's problem 24. And what it is just a straightforward application of the distance formula. So let me take a minute to remind you where that comes from. If I give us an x and y chart here and define 2 points, P1, which is x1, y1, and P2, x2, y2. Find the segment between them and call the distance between them, length of that segment, call it D. And I'm going to find D by recognizing that this point on the x-axis below P2 is x2. This point on the x-axis below P1 is x1. And this length along the x-axis from here to here, this side of this triangle, if you will, is x2 minus x1. Now, the distance from the origin to here is x2, the distance from the origin to here is x1, so this distance is this minus that, x2 minus x1. And in the same way, this distance is the difference between y2 and y1. So now, if you just focus on this little triangle, don't know if that's showing up or not, this side has this length, this side has this length. Since this is a right triangle, d squared then is just equal to the differences in the x's squared plus the differences in the y's squared. And that's through the Pythagorean theorem. And that is the distance formula. So this problem just wants you to let P1 be the explicit point minus 1, 0, and let P2 be the explicit point 2, 4. And in this particular case then, this distance squared is the difference in the x's, x2 minus x1 squared, plus the difference in the y's, y2 minus y1 squared. And when I do this arithmetic, this d squared is 2 minus minus 1, or 3 squared. 4 minus 0 is 4 squared, and that maybe you recognize the Pythagorean triplet 3, 4, 5. If you don't, you can see that this is 9 plus 16, 25, 5 squared, so d is equal to 5. And that's the end of the problem.